Hi everybody, it's Mr. Shea. We're going to go over math test corrections. This is the Unit 5 functions assessment. We're going to go through each problem, every single one. You can correct the ones that you need to correct, or you can do the whole test over again. I'm going to go through problem by problem. Follow along with me. You have a copy of this test on your Google Classroom, on my Google Classroom, and it's organized by your name, so you should be able to find it in the classwork section under your name. You can either print it out or you can write the answers on a separate sheet of paper. I suggest showing all of your work to show that you understand it and work through every single problem exactly the way that I'm working through it. Okay, it's going to take a little time. I want you to learn from this, not just write down the right answers. Okay, so here we go. Here's problem 1. And the question is, which equation represents a function of x that is not linear? Now remember, linear means line. So it's a straight line. So we're looking for an equation here that is not a straight line. Okay, and if I look at the very first one, y equals 4 times x plus 3. I can distribute that and I get y equals, and then I multiply the 4 times x and the 4 times a positive 3. I get 4x plus 12. And that is an equation of a line, so that's linear. So we're going to leave that one. That is not that's not the right answer. And then if I look at b, now remember, linear equations, y equals mx plus b, right? So this is actually in the form y equals mx plus b. This 4 squared is 16, right? So this is going to be 16 plus 3x. And if I rewrite this, it's y equals 3x plus 16. That is a linear equation. Okay, here we have a problem. We've got this term, which has x squared, okay? So x squared poses a problem for us when we have a linear equation. You can't have a variable with an exponent. So this one is, excuse me, this one is not a linear equation, okay? And it's because of this x squared term. This one is a linear equation because it's got a variable in the numerator, a number in the denominator. This is okay. This follows the rules for linear equations, so that is not the choice. So the right answer is C. Okay, one down, and I don't know. We've got a bunch to go. All right, here we go. Number 2. At a factory, the cost of making different numbers of toothbrushes is shown in the table below. So we have a table with the number of toothbrushes and then the cost in dollars. A linear function models the cost based on the number of toothbrushes made. Which statement about the rate of change of this function is true? All right, let's read the answers first, and then we're going to see what we need to do. The cost increases by $1.50 for each additional toothbrush made. The cost increases by $4.50 for each additional toothbrush made. The cost increases by $9 for each additional 3 toothbrushes made. Or the cost increases by $18 for each additional 3 toothbrushes made. Well, there's some expensive toothbrushes there for a few of those, so unreasonable answers. But let's take a look at this, all right? So the number of toothbrushes is 3, 6, 9, and 12. I want to see what the change is between each of those numbers. Okay, so from 3 to 6, that's plus 3. From 6 to 9, that's again plus 3. And then from 9 to 12, that's plus 3. Okay, so we have that. From $4.50 to $9 is plus $4.50. From $9 to $13.50, again, $4.50. And I bet you can guess that this is going to be $4.50 as well. So we have to look at our our rate of change here, which of course we always do, change in y over the change in x, which is equal to, so the change in y is $4.50, and the change in x is 3. So this is a division problem, isn't it? So I have 450 divided by 3. 450 divided by 3 is $1.50. So the rate of change, our slope, okay, is $1.50. All right? So the correct answer here is A, that the cost increases by $1.50 for each additional toothbrush made. You see, we're talking about each additional toothbrush, not every 3 toothbrushes. It increases by $4.50 for every 3, but for every single toothbrush that's made, the cost increases by $1.50. Answer is A. All right. Here we go. Let's take a look at this. We've got a coordinate plane here. We've got some lines. And the question is, the graph of the function is shown on the coordinate plane below. Okay. We've got some lines. We've got some curves. We've got a whole bunch of things going on here. And the question is, which statement correctly describes a function of the function on a given interval? All right, so let's take a look at A. A is the function is decreasing and nonlinear between x equals -7 and x equals -4. So x equals -7 is right here. Okay, so that's that point. And x equals -4 is right here. Okay, so what we have between those 2 points is an increasing nonlinear line, right? It's curved and it's going, and it's in an upward trend. That is not, it's nonlinear, but it's increasing, so that's not the answer. The function is increasing and linear between x equals -4, so there's x equals -4, and x equals 1, which is right there. Okay, so between these 2 points, okay, the function is increasing and linear. Look at that. This line is a horizontal straight line. There's no increase or decrease. Not correct. Okay, and then C, the function is increasing and linear between x equals 1, which is there, and x equals 4, which is here, okay? So we have a line that is increasing, but it's curved. So if it's a curved line, it's not linear. So that is not a good answer, and I'm hoping it's D, because we are in trouble if it's not. Okay, so let's take a look. So between x equals 4 and x equals 11, is D is referring to, must be. And it's decreasing, okay, and nonlinear. It's a curve, right? So it's not a line, it's a curve, nonlinear, decreasing, nonlinear. We got our answer. It's D. Okay, all right. Let's take a look at number 4. Which set of ordered pairs, and of course an ordered pair is always an x and a y together in the parentheses, could represent a linear function of x? Okay, now remember, functions are one thing. Linear functions are a little more complicated. Okay, so what we really need to do for each one of these is set up a table. The table is going to show us, we can't just look and see if it's a function, because a function isn't necessarily linear. Linear, it means it's a straight line, and for it to be a straight line, it has to have a constant rate of change. So we're going to set each one of these up in a table. So A, I have, okay, my x and my y, and I have -2, 8, 0, 4, 2, 3, and 4, 2. Okay, so to go from -2 to 0 is +2, 0 to 2 is +2, 2 to 4 is +2, 8 to 4 is -4, 4 to 3 is -1, and 3 to 2 is -1. And you can see that this is not a constant rate of change. That is, it may be a function, but it is not linear. Okay, so let's take a look at, so that's A. I'm going to label this just to keep track of things. Here's B. We have X and a Y. Now I'm not even going to do anything for B because I can tell right now it's not even a function because my input is 1, my output is 2. My input is 1, my output is 3. It's totally not a predictable thing. This is not a linear function. It's not even a function. So we're going to cut that one out. C, let me just double check here and make sure that it's possibly a function. It is definitely a function because each output has a input, all right? There's all different inputs and different outputs, so we can look at that one. So let's take a look. I'm going to just change this to C. All right, and I've got my X and my Y. I've got -2, 7, 0, 12, 2, 17, and 4, 22. Okay. -2 to 0 is +2. 0 to 2, another +2. And here's a +2. So far, so good. 7 to 12 is +5. 12 to 17 is +5. And look at this. 17 to 22, +5. This has a constant rate of change. My change in Y is 5 every time. My change in X is +2 every time. Therefore, that is a linear function. I like it. All right. Should we check this last one? I think we should. Always got to be sure. And you can see they've made it easy for us. This isn't even a function because here we have an input of 3. Here we have an input of 3, but they have different outputs. That cannot be not a function, not linear. There we go. So your answer for 4 is C, and make sure you look at, first of all, you can see if it's a function, and then to see if it's linear, you have to put it in a table and see if it actually has a constant rate of change. All right, so there we go. Got that one. Get rid of that paper. All right, moving on. Number 5. Okay. In each table, X represents the input value and Y represents the output value. Which table does not represent a function of X? Now remember, we have to have, for every input, it has to be consistent output, right? We can't have, if we put something into a machine that makes donuts, we're going to expect that it makes a donut every time, right? If we put something into that donut machine and it spits out a ham sandwich, we're in trouble. It's not working. Same thing with functions. We want to know that for every time that something is input into the machine, we have to have the machine is doing the same thing every time to that number, and we have to have a consistent result, okay? So here we have 0, 1, 2, 3, all different inputs, and 0, 1, 2, 3 different outputs. That one's okay, all right? So this one is a function. I'm going to just say this, okay, it's a function. B, we have 3, 2, 1, 0, all different inputs. 0, 1, 2, 3. As long as we have all different inputs, okay, we should be okay. So this one's good. 0, 1, 2, 3, and we have all the same outputs, which is okay. it's still applying the same rule. Here the rule is when I put in a number, the answer is always 3. Kind of a weird one, but it works. It follows the rules, okay? This one, it must not follow the rules. Because when I put in a 3, I get a 0. Sometimes I put in a 3, I get a 1, a 3 and a 2, a 3 and a 3. Nope, this one, not a function. Okay, because of this, right? So when I put in 3s, I never know what I'm going to get out, which is not going to work for me. Okay, here we go. Same idea. We're evaluating to see if these graphs are functions. Now remember, when we look at a graph to evaluate if it's a function, okay, same rules apply, but the way to visually see it is the vertical line test. So remember, vertical line goes up and down. So here I have, this is called a parabola. It's like this U shape. Sometimes they're U-shaped, sometimes they're upside down. But if I put vertical lines through here, straight up and down, every time I put a vertical line through, it only goes through that graph one time, okay? It only goes through this parabola once, at one point, each vertical line. So this one is, okay, oh, you know what? It's a linear function. This is a function. Function, yes. Okay, but that's not what we're looking for. We're looking for a linear function. All right, we got to read the directions carefully. So this is not linear. Okay, this next one, not a line, not linear. This is linear. No. This one, function, yes. Linear. No. This one, as you can see, if we did the vertical line test, it's a function. It is a straight line. This is linear. Yes. Function. Yes. There we go. That's going to be our answer. Because look at this one. Even though it's linear, it's a straight line. That means it's linear. This is linear, yes. But if I try the vertical line test, it just kind of follows that line. Every single point on this one is along the line. So function, no. Okay, there we go. That one's not good. All right, so the answer for number 6, show your work, do linear. You have to evaluate 2 things. Is it linear and is it a function? Function, vertical line test, make sure. Linear, we can see right away. This, not linear. Linear, if it's curved, not linear, we can eliminate those right away. Okay, here we go, number 7. Which function of x has the least value for the y-intercept? Remember, y equals mx plus b. Which one is our y-intercept? Is the b value, okay? We want to see which one has the least value. So we have 2 equations and we have 2 graphs to look at. So we want to see which one has the least value for the y-intercept. Y-intercept here is positive 15. Y-intercept here is negative 3. That's our leader so far. Y-intercept here where it goes through the y-axis is a negative 2. And here where it goes through the y-axis is a 2. Therefore, this one has the least value for the y-intercept, which is negative 3. All right, here we go. Kevin's savings. All right. Kevin and Christy both saved money for their class trip. Kevin saved the same amount each week. The total amount that Kevin saved at the end of every 2 weeks is shown in the table below. So here we have Kevin's savings. time in weeks, total amount saved. Christie's savings can be modeled by the equation y equals 26x, where y is the total amount of money saved in x weeks. Which statement correctly compares the rates at which Kevin and Christy save money? Let's look at the answers just so we know what we're looking for. Okay, A is Christy saved $3 per week more than Kevin. B, Kevin saved $10 per week more than Christy. C is Kevin saved $18 per week more than Kevin. And D, Kevin saved $20 per week more than Christy. All right, let's take a look here. We need to see, here we have Christy. There's the equation for how much she's saving. So if it's y equals 26x, what does that tell us? Y equals 26x. How much is she saving per week? This is the rate of change right there, right? 26. Every week, which is x, she is saving $26, okay? So Christy is saving 26 per week. We have to see how much Kevin is saving, and then we can compare them. Kevin, every 2 weeks, right? 2 to 4 is 2, 4 to 6 is 2. Every 2 weeks, plus 2, he is saving 46 to 92. We got to do a little math here. What is 92 minus 46 is 8, 2, we have 6, 46. So the change in y over the change in x, so each time he is saving 46 plus 46. So the change in y is 46, and the change in x is 2. So every 2 weeks he's saving $46. How much is he saving every week? So if he saves 46 in 2 weeks, he is saving 23 in 1 week, okay? Because anytime we have a fraction, it's just like a division problem. We just divide 46 by 2, we get 23 in 1 week. $23 per 1 week he's saving. So Kevin is $23 per week. Okay, let's take a look at the answers. Christy saved $3 per week more than Kevin. It's true, right off the bat. We got it. Let's just double check here. Make sure these answers aren't surprising. Kevin saved $10 per week more than Christy. Not true. Christy saved $18 per week more than Kevin. Not true. Kevin saved $20 a week more than Christy. Not true. There we go. There's our answer. Here's how we figured it out. Make sure you have all this information. You have to find what the rate of change for Christy, that's obvious. 26x, $26, x is the weeks. Remember, this is x, this is y, okay? And then for Kevin, we figured out what the rate of change is. We got $46 every 2 weeks, which is $23 in 1 week. We can see pretty clearly that Christy is saving $3 per week more than Kevin. All right, now we go on to number 9. Here we go. Do we have a number 10? We do. We are 2 problems to go. Okay. The table and graph shown below each represent a function of x. So the question is, which function, a or b, has a greater rate of change? Be sure to include the values for the rates of change in your answer. Rate of change is the same as the slope, and so we can easily calculate that for both of these. For rate of change, we want to know what the change in y is over the change in x. So let's take a look at this function a. So from 1 to 2, that's a +1. 2 to 3, +1. 3 to 5 is plus 2. And 5 to 6 is plus 1. And 5 to 7 is plus 2. 7 to 9 plus 2. 9 to 13 plus 4. 13 to 15 plus 2. And when we look at this, we see that for the first set of numbers, we've got a rate of change of, when we're comparing it, 2 over 1. This is 2 over 1. This is 4 over 2, which is equal to 2 over 1. 2 over 1. So the rate of change here, our slope, x change in y over the change in x, is 2 over 1. Our m, right, is 2. And we have to understand that, know it. M stands for the slope. M is the rate of change. It's the change in y over the change in x. Our m here is 2, okay? Let's see if this one has a greater rate of change. Let's pick a couple of good points here, a couple of nice points. Here we have a nice point at 1, 1. Now, let's take a look here. Just to be sure, let's take a look at our scale. It goes up by 1. That really works. That's helpful. And this goes up by 1. That's really helpful. So this is going up by 1s. This is increasing by 1s as well. Very easy to figure this one out. Okay. So here I go from 1, 1, and here this next nice point is 2, 4. So x is 2, y is 4, and then here x is 1, y is 1. My rate of change, so it goes up from, let's do this real quick. X, Y, my X is 1, my Y is 1, my X is 2, my Y is 4, or I could just count, because since this goes up by 1s, I'm just going to count. It goes up 1, 2, 3, it goes up 3, plus 3, and then it goes to the right 1. So this is my change in Y is 3. My change in x, change on the x-axis is 1. So this one is 3 over 1. Okay? Function B has a greater rate of change. Okay? Y, the rate of change for A is 2 over 1, and then the rate of change, I'm just going to do this, save a little time. The rate of change for B is 3 over 1. That's a good answer. That's all we need to do for that one. All right, flip it over. Here we go. Number 10. A car repair shop charges an hourly rate plus a pickup and delivery fee. The graph below represents the relationship between the total cost of the repair, including pickup and delivery fee, and the number of hours it takes the shop to complete the repairs. Okay. What equation represents this linear function? All right. Now remember to write the equation of a line, which is y equals mx plus b. We need these important pieces of information. We need an m, which is, of course, the rate of change, and we need a b, which is the y-intercept. Okay, we can easily calculate that from here. Let's take a look at this graph first. It goes from 0 to 25, 25 to 50, 50 to 75. So each line represents an increase of plus 25, right? It's not going up by ones. We're not counting by 1 here. We're talking about repairs for a car. If we did it by ones, repairs are expensive. Wouldn't fit on the graph, so we have to go up by 25s. The number of hours, that goes up by 1. All right. So now we have something we can work with. All right. So write what equation represents this linear function? So we have y equals mx plus b. I need my m and my b. I can look at the graph to find what b is. Remember that b is where the line crosses the y-intercept. It's our starting point. So this represents, okay, this 75 represents when you bring your car into the shop, the pickup and delivery fee, that's the flat fee, $75. Okay, that's B right there, total cost in dollars. That's my starting point, that's my B. The rate of change, that's how fast is this line increasing, right? So if I go, here's 1 and 125, there's 2 and 175, and at 0, it's 75. Okay, let's just create a little table here with my X and my Y. Let's go with these 2 points, okay? So at 1, when X is 1, my Y is 125. And when my X is 2, my Y is 175. Okay, I'm going to put those numbers into my table. So when X is 1, I've got 125. And when my X is 2, I have 175. So this increased by 1 plus 1. That's great. I'm not going to have to do any crazy math there. And from 125 to 175, this is plus 50. So my change in Y over the change in X is equal to 50. The change in Y is 50. And my change, not 56, 50. My change in X is 1. It's $50 an hour. Do you see that? In 1 hour, okay, every single hour, starting at $75, every hour we're adding $50 to the bill, okay? So this mechanic is charging $50 an hour. That's our rate of change. That's our M. Okay, remember, here's our equation of a line. Y equals mx plus b. We need the M and we need the B. And this will tell us, without fail, how much it will cost for the given number of hours, which is X, how much the total cost will be, which would be Y. Okay, so I keep the Y. I'm going to substitute for my M, I have 50. Still have the X because no matter how many hours, X number of hours could be 1 hour of repair, could be 4 hours of repair. I just would plug it in there. So I'm going to leave it at X because this could be any number. So the X could be any number. I'll leave it there. 50, every 1 hour is $50. X, and then the starting fee is $75. So I'm going to put that there. There's my equation. Y, the total cost, is $50 an hour per hour, plus that $75 initial fee. There we go. And that is my equation for the line in order to be able to figure out how much it's going to cost to get my car fixed. All right, that's it. I hope you enjoyed the video. It's my first one. And I miss you guys. Hang in there. Hope everything's going well at home. I'm going to post this right now. You can get on the math test corrections. If you can write this on a separate sheet of paper, you can. If you want to use the that PDF form where you can write on the PDFs, that DocHub app that's on your, or the extension that's on your Chromebook, you can use that. But one way or another, get these corrections done, hand them in. We'll give you credit, and see you soon.